an exam yesterday. So Saturday after today's class, I'll be a bit more free. So I'll decide. I'll fix up the course. In fact, your course and Indian economics course have to fix up. After that, on Monday, I'll ask you, or I'll send
Okay,
a mail,
sir.
or I'll send a mail. You can do it. I mean, roughly, when would you like the doubt clearing class?
Sir, next week.
You, okay.
Sir, I mean this coming week.
Mm-hmm. Okay. So wait a minute. Where's my class? Okay. So in the last class, we had looked at expansion paths. If the cost is increased, keeping wage and the input prices constant, or just the input price ratio constant, then the isocost line will shift outwards. And the shift will be a parallel shift. So in that case, we are going to have a new equilibrium, a new tangency point between the isoquant and isocost. And if we take the locus of all such tangency points, we will get the expansion path. In case of a homogeneous production function, we showed that the the input combination, labor capital combination, is a straight line from the origin. So if the isocost line shifts parallelly, then the resultant expansion path will be a ray through the origin. So over here we can see that we have three different expansion paths. Along this expansion path, the labor capital ratio is constant. Along each of these expansion path, the labor capital ratio is constant. But if you compare between the three rays, the labor capital ratio will obviously vary. Okay. So then we turn to homothetic production functions. A homothetic production function is a transformation of a homogeneous production function. It is a monotonic transformation of a homogeneous production function. The most important property of a homothetic production function is that its expansion path is linear. So we have proved this over here. And then we distinguish between economies of scale and returns to scale. See, economies of scale occurs when you're simply increasing inputs. They can be in any ratio. Okay. So maybe you increase just labor, maybe you increase just capital, you double labor, but you treble capital, whatever. So you're not seeing anything about the labor capital ratio or input ratio. You're just increasing the inputs and seeing what happens to output. If the average cost falls, we see that we have economies of scale. If the average cost increases, we see that we have diseconomies of scale. We can also have a flat portion where the average cost is constant as we increase output. And we see that in this point, the economies balances with the diseconomies. Returns to scale is a very special case of economies of scale. When the labor capital ratio is held constant, you simply increase both by the same amount. So if you double labor, you double capital. If you treble labor, you treble capital. Sorry. Now, if you change the labor capital, if you increase the input, keeping labor capital constant, you're going to move up this linear expansion path. Now, the question is, how much do you move? I mean, what is the new output level? So here you can have three possible cases. I mean, you can have n greater than 1. So which means that output is, suppose you increase labor and capital by 2 times, then labor capital, then the output will increase by more than 2 times. This is called increasing returns to scale, and n is greater than 1 in that case. The other extreme is decreasing returns to scale. So you double labor and capital, but output increases less than double. You can see it increases from 100 to 150. So here the value of n, the degree of homogeneity, will be between 0 and 1, and we call this decreasing returns to scale. And finally, you have constant returns to scale when n equal to 1. In this case, if you double labor and capital, output will also double. So n is equal to 1. So I had closed by introducing the concept of elasticity of substitution. When when the WR ratio changes, then let us suppose that wage goes down, the isocost line is going to rotate. It will not be a parallel shift. It is going to be a rotation. Since only wage rate has decreased, we are going to have an outward rotation, keeping this point constant. So the capital axis, this point is constant. The labor axis point is going to move outwards. So then the question is that fine, we are changing, W has changed for some reason. How does the input combination change? And this is given by elasticity of substitution. We know that if W becomes cheaper, the firm will employ more of labor, less of capital. The firm will substitute cheaper input labor for the costlier input capital. But what is the extent of change? This is given by sigma, which is elasticity of substitution. And this is the formula for elasticity of substitution. Now, the first part that I want to discuss is that we have been working with the Cobb-Douglas production function, and so let us stick to that and let us find out sigma over here. Okay. So I'm just going to use a notation just to simplify matters. So the small k is, as you know, labor capital, and well, I meant it to be omega, but this is equal to the WR ratio. Okay, so we just write it in shorthand like this. if you look at the equilibrium condition of the firm wants to maximize output subject to a cost constraint. Then the first order condition is right. This is for all types of production functions. Okay. Now, in case of a Cobb-Douglas production function, what was NP by NPK? What is MPL by MPK?
So minus alpha 1 by alpha 1 minus alpha.
Okay. Equal to
Sir, alpha by beta k by L.
in this case it is alpha
Sir,
by
beta
beta.
k by L. Sir, into k by
K
L.
by L into
Okay. And if alpha plus beta is equal to 1, that is, it is a constant returns to scale or homogeneous, linearly homogeneous production function, it simply becomes okay, instead of beta, you can write 1 minus alpha. That is what Pema Dorja had said. Okay. So that means your equilibrium condition is given by alpha beta k by L is equal to W by R. Okay. Now we can write this as k by L. This will become beta by alpha W by R. Okay. So if we use this type of shorthand, we can write সরি আমি উল্টোটা লিখেছি না, এটা আলফা বিটা হবে। ও না না, এটাকে তো আমি এই সাইডে নিয়ে এসেছি। এইটাই আমার বলে থিটা ইজ ইকুয়াল টু bring the brush back. আচ্ছা, okay. Now this type of production function, or rather sorry, this equation okay, it is in the form y equal to ax. Okay, don't worry about this if you don't understand why I'm writing this, but what is the average of this function? The average of this function is k by omega. Okay, so what is this equal to?
Theta.
আচ্ছা, the marginal product is this is also equal to theta. Okay. So if you have a production function in this form, y equal to ax, then it will exhibit the property that AP is equal to MP equal to A. In this case, A
So
is
can you
theta.
explain that part again? So how AP equals to P by that thing?
Okay, see over here, we are assuming that the K is equal to theta by theta into omega. Okay, so K is a function of omega. Now, how do we? So we can write this as in this form: y equal to ax when K is y, theta is a, and omega is x. Okay. Now, how do we find the average? Average is simply y by x, right?
Got it, sir.
So this is k by omega. It's theta. So this is by definition, and this is what it is equal to. Okay. So let us see. Now, if you look at the definition, what is dk by dw equal to? Let me write the definition over here. Sigma is equal to dk right. Now, what is this?
Theta.
Yeah, this is marginal product and it is equal to theta. And what is this?
1 by theta.
So, what is the elasticity of substitution of a Cobb-Douglas production function? It is always equal to 1. Okay. So, we get this result even if the function is not linearly homogeneous. Okay, we have taken the general case of alpha and beta, not the case specific case of alpha plus beta equal to 1. We hadn't taken this case. We have taken the general case. So that means for the general Cobb-Douglas production function, sigma is constant and it is always equal to 1. Okay. Now, I have taken some time about this because I'm going to use this result several times today. Then I'm going to discuss a very special case a very a special type of a production function when sigma is always constant. So whatever WR, whatever whichever point we are, sigma does not change. This is called, in short, a CES production function. This type of production function was proposed by Solo, Robert Solo, the Nobel laureate, Bagicha Minas, Kenneth Arrow, who was another Nobel laureate, and Hollis Chenery. So if you take the first letters of each of these authors, we get SMAC. So this constant elasticity CS production function, we call it in short, is sometimes also referred to as the SMAC production function. So this was proposed in a paper by these four distinguished economists in 1961. The problem with this is that it's rather complicated. Can you tell me why rho is not equal to 0?
So anything to the power 0 is 1.
So it's minus 1 by 0. It's rho is 0, then minus 1 by 0.
It will be infinity.
Exactly, undefined.
Yeah, the problem is over here. So let me just over here. So if you put rho equal to 0, then this will become undefined, and the production function, you're going to get a vacant point over here in this case. So that is why we rule out the value of rho equal to 0. And as you will see, that this will create some problems. Okay. So what I'm going to do is first I'm going to state the properties of the CS production function. So the first property is the CS production function is homogeneous of degree 1. So can you tell me what will be the returns to scale?
Constant returns to zero.
Yeah. Suppose we pay labor and capital an amount equal to their marginal products. What will be the profit in that case?
Zero because it will be exhausted by the product.
Yes, very good. The product exhaustion theorem is applicable for all linearly homogeneous production functions. So it's also applicable for the CES production function. Now, if you estimate the average and marginal products, are these AP and MP homogeneous?
So EP is homogeneous of degree 0.
Yeah. So if a production function is homogeneous of degree n, the AP and MP is homogeneous of degree n minus 1.
Sir,
Yes?
so are you writing anything in the board right now? In
No.
number 2?
No,
Okay,
no.
sir.
So CRTS, AP and MP, now I'm writing, are homogeneous of degree 0, and you have the product exhaustion theorem. Okay, the second property is that the isocons generated by the CES are negatively sloped and convex to the origin. Obviously, you have to put in the restriction that labor and capital are strictly greater than 0. And third is the value of sigma. This is equal to 1 plus rho. So you can also see that if rho was equal to 0, no, here rho doesn't create a problem. Okay. So we'll come back to this property later on. And the fourth property is something that it's a bit complicated. Okay, I'll state the fourth property later on. Okay, you've copied this? So I'm starting with the second property, that the isoquant R is negatively sloped. Okay. So first let us find out MPL and MP key. But before that, okay, so MPL is simply del Q by del L. Okay, so A is a constant. We write A over here. Then we have to differentiate this term. Okay, so we have to apply the chain rule. So we first differentiate this term, then we differentiate what is within the brackets. Okay, so if we differentiate this, we are going to get, so we just take this as something like this form, okay? And we differentiate theta. So this is simply, so the bracket comes and it will be 1 by rho minus 1, right? Then I have to differentiate theta. So now I'm doing theta, sorry, this is not dq, it is del theta by del L. Okay, so 1 minus del will come. Okay, the minus rho comes over here and I have L minus rho minus 1. Is this clear?
Yes, sir.
Yes, sir.
Okay, so a little bit of housekeeping. সরি, এটা তো রোটা ছিল। আচ্ছা, and this row cancels out. Okay, in fact, you have got minus 1, so both of them cancels out. এইটা আর এটা ক্যান্সেল আউট করে যাচ্ছে। ওকে, সো I have got 1 by rho। আচ্ছা, এখন এইখানটা তুমি দেখো, this part, if you just ignore this part, assume that this is equal to 1, তাহলে তোমার টার্মটা কি হচ্ছে? A is there, you have this part, okay, this is the, I'm simply writing the bracket, minus 1 by rho, minus 1 by rho, just ignore this part, okay? Suppose this is equal to 1, so this is equal to simply q as before. Achha, now I have got 1 plus rho, so what I can do is, I can take sorry, okay, so this is 1 minus del. Achha.
Sir, can you explain the third line once more?
This
A
one?
to the power, yes, sir. A to the power 1 plus rho by 1.
No, the only thing that I've done over here is, see, what is the power of 1? What is the power of A? It is 1.
Yes, sir.
So if I take 1 plus rho and divide by 1 plus rho,
Yes, sir, I got it.
it's still 1. Acha. Acha. Now what I'm doing is, I'm taking out this part. Okay? So that means I have got 1 plus rho over here. Look at this. Can you understand how I've got this? What I've simply done is, I have taken this out, 1 plus 1 by this. So the entire thing becomes q to the power of 1 plus rho. না না সরি, আমার এখানটা একটা ভুল হয়ে গেছে। এবার রাইট ওভার হিয়ার। How do I do it? No, I'm writing this in this way. See, this is a to the power of 1. So I'm writing this in this way. 1 plus rho minus rho. So the rho cancels out. It's still a to the a into 1. So that means it will be a to the power of rho. Okay. Now what was q? This is 1 meter. এখানটা নিয়ে নিয়েছি। In fact, this part also I can rewrite in a slightly different way. It's not a major change. Because it's minus, I can simply write as, okay. So this is a to the power of rho. Now what is this? 1 plus rho. Okay, so now just some housekeeping. Okay, can you follow this?
So can you explain the fourth line?
Wait a minute. Okay. See, what I have done over here is, let me break it up. So I'm looking at this
No,
part,
sir, I
okay?
understood that line. So the second part.
No, no. What I'm, yeah, I understand. No, what I'm saying, let me break this part up. Can I write this in this way? This is just this term.
Yes, sir.
Okay? Okay. Now what is this? Ignore the 1 plus rho. This is simply this part without A. Right?
Yes.
Acha, now how do I get the A? What I can do is, this is 1 plus rho minus rho. So minus rho I take over there. I take A within brackets. And 1 plus rho is common. The power is common.
Got it, sir.
Okay, so this is something that you will have to do on your own. I'm showing you this derivation, but unless you do it on your own, you're not going to be able to do it. Okay, so therefore, the term that we are getting for marginal product is this.
So that means you might ask us to do this entire derivation in the physical exam, in the 70
Uh,
questions.
yes, but if you think that this is tough, then wait a little bit for the next part. The
So why must you
CS.
scare us like this?
Okay. And what is MPK? MPK also you can show. Sorry. Okay. So you have got MPL, you have got MPK, right? So MPK I have not derived, but try to derive this on your own. I mean, unless you do it, you will not get the confidence to work it out by yourself during exams. Okay, so this is what the results that we require. Now see, the CS function is like this, right? So dq is simply FL dl. We had proved this before, but dq is 0. So dk by dl is equal to minus FL by Fk, which is the marginal products. Okay. So that means the slope of the isocont is equal to minus MPL by MPK. And what is this? 1 minus del by e to the power of rho QL 1 plus rho right? Now this a rho and a rho, a to the power of rho will cancel out. So we have 1 minus del and del from here. The q and q cancels out. Okay, so k will simply go to the top. It's q by L and the power is 1 plus rho.
So there will be a minus sign before
Sorry,
one minus.
I forgot the minus sign. Yeah. So if you remember the specifications, what is the value of del?
It lies between 0 and 1.
Okay. So when can it, this will always be positive?
Yes, sir.
Del itself we have straight away said was positive. What is k by L? Positive. So this entire thing term within the brackets is positive. So that means if you put a negative sign in front, the slope of the isocont will be negative. Okay.
Yes, sir.
Okay. Now I'm not showing the second part, that d square k by dl square is positive convexity. But let us turn to the last part, the elasticity of substitution, the value of sigma. Okay. Now again we start from the point that in equilibrium, this condition is satisfied. In case of the Ces production function, what is the ratio of MPL by MPK? I have forgotten. Can you please tell me what is this ratio?
So 1 minus
Minus
delta.
1 by delta k by L to the power 1 plus rho.
1 plus rho. So this is equal to W by R. Okay, now we can write this in this way. Let us suppose that this is theta. Right, it's a constant theta. Instead of KL, we write it in short. Actually, technically, it's 1 by K. In fact, and we write this as omega. In fact, it is better if we write it as 1 by K. Okay, now, in fact, I shouldn't have taken theta over here. This is going to add to the confusion. Okay, anyway. So we can write this as, we still keep it as KL. This is right. I've not brought in the theta still. And if you bring the theta also now, it's going to be like this. So we write this as, let us say, C, which is a constant. Okay. Okay. Now, what is the marginal function, which is equal to the average function? Well, I mean, this is again equal to the key, the form that I showed you. Right. So this is in the y equal to ax format.
Here there is a power over.
Yeah, we have a power, but we can see that this is x. Oh, no, you're right over there. Okay, so what is the marginal of this? The marginal function is, I'm going to run out of space. We take this is C. This will be 1 plus rho, and this is okay. So let me write this as 1 plus rho omega. এটা কি হচ্ছে? See that this will be 1 plus rho. Okay. The average function is Q by L divided by omega. So let me see, this will be, this is C. It is okay.
মাইনাস রো হবে হবে না করে
Minus,
রো
sorry, minus minus rho যদি হয়
না স্যার মানে ওমেগার ওপরে মানে ওমেগার পাওয়ারে মাইনাস টু।
না না দাঁড়া দাঁড়া আচ্ছা এইটা 1 চলে গেল। হুম হ্যাঁ এখানটা তুমি কি বলছো কোথায় ওমেগা আসবে?
না স্যার বলছি ওমেগার পাওয়ারে মাইনাস টু বাই ওয়ান প্লাস টু হবে না? এই লাস্ট লাইনটাতে মানে
হ্যাঁ
ওমেগা টু দ্য পাওয়ার
এখানটা
ওয়ান
সি চলে এলো। এইটা হচ্ছে 1 বাই 1 প্লাস রো।
মাইনাস ওয়ান সেখান থেকে।
হ্যাঁ এখানে -1 এলো।
আর তারপরে তো ওয়ান মাইনাস জিরো।
আচ্ছা আচ্ছা হ্যাঁ আচ্ছা আর এইখানটা কি হবে? এখানেও তো তোমার একই জিনিস হচ্ছে,
হ্যাঁ ওখানে মাইনাস ওয়ান।
এখানেও একই হচ্ছে।
আচ্ছা বলছি থিটার ভ্যালুটাতে তো একটা উপরে ওয়ান বাই ওয়ান প্লাস টু থাকবে না? এই যে থিটা ইকুয়াল টু ওয়ান মাইনাস ডেল বাই ডেল রয়েছে।
না এইখানটা আমার থিটা কি বাই এল, ধরো একটা পাওয়ার আছে এক্স ইকুয়াল টু ডাব্লিউ ওমেগা।
জাস্ট আমি এই পার্টটা বলছি থিটা ইকুয়াল
হ্যাঁ
টু ওয়ান
ঠিক আছে
মাইনাস।
থিটা ইকুয়াল টু, হ্যাঁ ওটা করলেও যেটা হবে এখানে তোমার 1 প্লাস রোটা চলে আসবে, কিন্তু সবটা নিয়ে আমি ওটাকে সি বলে দিতে পারি, বিকজ রো ইজ অলসো কনস্ট্যান্ট, আর থিটা যে টার্মটা ডেল্টা দ্যাট ইজ অলসো কনস্ট্যান্ট। সো বেসিক্যালি আই গেট সামথিং, আই গেট আ কনস্ট্যান্ট উইচ ইজ সি।
ওকে স্যার।
সো মার্জিনাল বাই অ্যাভারেজ এইটা আমি যদি দেখি, ঠিক আছে এই পার্টটা ক্যান্সেল করে যাচ্ছে, সি সি ক্যান্সেল করে যাচ্ছে, সো ইট ইজ সিম্পলি 1 প্লাস ডেল। ঠিক আছে লেট মি জাস্ট ডু ওয়ান থিং and I'll come back. ঠিক আছে so shall I show this again?
So,
Yes.
so I have a question. So,
Yeah.
however SM has taught us, so can we do that style also, like that in that way also?
Which style?
So, like SM has did it in easy way, but so like
Yeah.
SM took different approach. Like she took a alpha to the power L to the power rho and all, not minus rho.
Actually this is the problem. I have to Yeah, what did she do?
So like the main function only, sir, she took it as q equals to a alpha to the power
Wait,
alpha
q
a
is
to the
equal
power
to
rho
q is equal to a alpha.
alpha L to the power rho plus 1 minus alpha k to the power rho by
No,
1 by rho.
no. Will you just repeat what she said?
So
A into
a
yeah.
alpha
Okay,
L to the power rho
L to the power rho.
plus
Hmm,
1 minus alpha
1 minus alpha
k to the power rho by 1 by rho.
by 1 by rho. No, you're taking some power.
Yes, sir. Yes, sir.
Yeah.
By 1
Okay.
by rho. So I don't think there's a minus.
No, there won't be a minus. No, but see over here, one thing is clear. What she has done is she's simply juxtaposed L and K. In my case, I mean, the way that I have defined this, see, alpha and del is nothing. This is minus. Okay, so if you take minus over here, minus 1 common, this will become rho. This will become rho. She's not getting any taking any minus over here.
So we are there? No, sir. I don't think so.
No, sir, she's not taking.
No, but the font. See this part, instead of del, she's taking alpha. Okay, so that is not a difference. Then what she's doing is she's changing labor and capital, the position. But
So in all the powers, instead of minus rho, she has taken rho. So where she has also taken 1 by rho.
okay, okay, I understand. What she has done is um, rho instead of rho, you can say it's theta. So this will be 1 by theta in this way. She's changed the signs. She's changed the notation. Okay. Now there's another way in which you can find out the elasticity. Let me first write the production function. Q is equal to del K minus rho This is, you're just saving one part. So this is equal to okay, this is 1 plus rho, so this will be minus rho 1 plus rho. So if we take log, this is log C. So the elasticity of substitution is simply so this is 0. I don't remember. Was there, let me see, what was the exact derivation? এইটা কি হচ্ছে? 1 plus rho minus 1 is 1 minus okay. ওহো, এটাকে আমি কেন এটাকে করতে গেলাম? Sorry, just 1 minute. Okay, I've got log dk log c minus rho এই ফর্মটা চলে এলো। So if I sorry, the sigma will not come here. Oh, I've written this part wrong. I've written this part wrong. That is why I'm getting the error. Okay. I wrote the marginal product actually. Okay, so if I take log, I'm going to get log C 1 plus rho log omega. So if I differentiate, I'm going to get 1 by KL log C 0, and I'm differentiating with respect to log W. So I'm only going to get 1 plus rho by 1 by W. Okay, so if I take W over there, this will be log K by L d log W is equal to 1 plus rho. Now this is the elasticity of substitution. So it is 1 plus rho. So instead of doing it by the marginal by average function, you can do it in a slightly different way, that you can use this part, this relation, take log and then differentiate. So this is one way of doing it. And this is the other way of doing it. Okay. And what is the other way, that the third way that you're suggesting?
So the thing, so we just like find the MRTS and do it. Also MBL by MPK.
Yeah.
So, and then like we put the values of sigma equals to
How do you put in
d.
sigma? That is what we are trying to find out.
So out here, so we found it like, so we first find the MPL and MPK.
Yeah.
So then, so ma'am has differentiated that MRTS by DKL, D delta MRTS by delta DKL.
Wait a
So
minute. Wait a minute. Sorry. You found out MPL by
yes,
MPK.
okay, yes sir.
Yeah.
So
This
then,
is marginal. Yeah.
yes sir. Then so she found delta MRTS by delta K by L.
Sir, he's talking of the
And she is
elasticity
taking at
formula.
sigma. Sigma
Sigma
is
is
equal to
equals
delta
to
MRTS by
So
delta
sigma.
K by L.
So it is delta K by L by delta.
exactly, it is delta K by L by delta MRTS into
Yeah. It is
MRTS.
delta K by L by delta MRTS.
No, so
Yes,
then we
sir.
can reverse it. No, so like if we
Yeah.
find
Yeah.
that
We can
sigma
reverse
value,
That
this.
is
That is
1 by
not a
so
C.
problem. No. No. What you're saying is this, right?
Into
yes, so
MRTS
MRTS by K by
by
L.
K by L.
Yes, we can write it as this again.
Yeah, this is what he means.
No. See, the problem over here is, why is MRTS changing? do you think that the MRTS changes and this leads to a change in KL?
No, sir, we are doing with respect to quantity. So we have done Q
No,
equal to
wait.
A.
What you're doing over here is you're saying that MRTS is changing with respect to KL.
Yes, sir.
Yes, sir.
So basically, if you're saying like this, how can you argue this? See, what is happening over here is W by R is changing. This is leading to a change in KL. This will lead to MRTS changing. So you've got to get the process right. The answer may be, you may get the same answer,
Getting a
but
bit
the
confusing.
intuitive structure has to be correct. See, there's also a way in which you derive the cost function. If you can do it like this, minimize cost equal to or what you can do is, if you read Kutsani's for instance, okay, both will give you the same type of cost function. You'll get a cost in terms of output. The problem is that if you follow this method, this is wrong. We find out the cost function in this way, that we choose a particular level of output, and for that output we are finding out cost. Okay, so this type of structure is appropriate to derive the cost function. Similarly, over here, your change has to be with respect to W by R. You can't put in a different value. MRTS is not changing, it's W by R which is changing. That is leading to a change in K by L, which is leading to a change in MRTS. So you have to start from here. Unless you start from here, you will not get you may get the correct answer, but your thought process is wrong. It's not a case of easy or difficult. Are you understanding my logic?
Yes, sir.
Yes, sir. So that means the way you have done it, মানে আমরা যখন definition লিখবো, we'll write it that way. That is the correct procedure.
না দেখো এইখানে যে ডিফারেন্সটা, see when you are writing the production function
Sir,
in this way,
I'm a bit confused.
you can
like
bring
explain
you
one
can
more
bring
time?
capital first or labor second. That's not important. Instead of I've written 1 by row, সেখানে তুমি যদি রো কে ধরে নাও মানে minus rho is assumed to be, let us say, theta. You can change it in that way. That is, these are not important. What you're simply doing is, in that case, this is the original form as Mac derived it. What you're simply doing is, you're changing the formula, you're changing the symbols a little bit. মানে ধরো আমি কপ ডগলাস প্রোডাকশন ফাংশন যদি এইভাবে লিখি, আর আরেকজন এসে যদি এইভাবে লেখে, is it wrong? Both of them are the same. So this
Yes.
part, what has been written, you can write anything that you want. That is not important. But when you are deriving the elasticity of substitution, in that case, you have to realize this part, that W by R is changing. See, what is the definition of MRTS? What is the definition of elasticity of substitution?
Percentage change in K by L due to 1% change in W by R.
Yeah, the correct definition is, when the input ratio, I'm reading from Chiang, when the input price ratio rises, we will normally expect the optimal input ratio to rise. Okay, so When W by R is changing, L by K will also change because labor is now relatively cheaper. It will be substituted for capital. The direction of substitution is clear, but what about its extent? The extent of input substitution can be measured by the following point elasticity expression called the elasticity of substitution and denoted by sigma. Sigma defined as relative change in labor capital ratio by relative change in price ratio. Okay, so you have to the causal change is W by R. You cannot assume that the causal change is MRTS. It may be equal. At equilibrium, MRTS is equal to W by R. But if you introduce MRTS over here, it will be your derivation will be conceptually wrong. Okay, but what you can do is I mean, will you find it a bit difficult if to follow two derivations? The answer is yes.
Yes,
তাহলে
sir, a little bit. I mean,
আচ্ছা
a
ঠিক
lot.
আছে, তাহলে এসএম এ যেটা সেটাই ফলো করো। ঠিক আছে, কারণ এইটা আমি যদি তোমাদের পরীক্ষায় রিটেনে দিই,
What is the difference? Because both of you are deriving the production to the MRTA. So, like,
ডিফারেন্সটা ওটাই আমি বলছি যে হোয়াট ইজ
is it
so say the
is any
difference just
process
now.
wrong? I think both
So
are
say the
correct.
difference.
ওফ, হ্যাঁ বলো
So say the
ডিফারেন্স।
difference just now. Like we follow SM followed from like MRTS to change in KL, K by L, whereas sir the actual process is W by R should change because W by R should change, then K by L should change, then
Then K
MRTS.
by L should change, which changes to MRTA. So, got
Yeah.
it.
আচ্ছা, যেটা হচ্ছে দেখো, যদি তোমাদের আমি অঙ্ক করতে দিই, তোমরা পুরো চিয়াং খুলে টুকবে, তাই তো? রিটেন দিলে,
So I don't understand.
ও সরি, if I give this to you as a problem in your written exam,
স্যার
you are going to
তাহলে
open
কি আপনি পুরোপুরি চিয়াং থেকেই দেবেন?
no, what I'm asking
That's
is,
the main question.
no, I'm trying to solve your problem logically. If I suppose I've today you have a written exam and I've asked you to find out the elasticity of substitution. What will you do? Will you derive it? Or will you simply open Chiang and work out the problem?
Sir,
এইটা
we
আমাকে একটু
will
বলুন।
derive it. মানে যদি SM এর মতন derive করতে হয় তাহলে পারবো করতে, কিন্তু আবার নতুন করে যদি বুঝে নিয়ে করতে হয় তাহলে তো
না
একটু
না বোঝা
problem.
না, ধরো আমি এই মুহূর্তে আমি বলছি বই খাতা বন্ধ করো, তোমাদের এখন টেস্ট স্টার্ট হলো। ওকে,
So question.
ও সরি, the class is over. I'm starting a test right now.
So we will derive the way you will derive. So we will try to derive it that way.
No, I'm not saying that.